Hello students, welcome to Eduxcite classes, and now we will discuss the third criteria, which is the analysis. So this is also 6 marks out of 24 and it focuses on the following areas, that is your raw data, your data processing, uncertainties and interpretation of your process data, that is the graphical analysis. Okay, so this is the most a crucial part of your investigation, which is defined how good your investigation is, because everything is depending upon the analysis part, how you analyze your investigation or your physics IE. Okay, so let us go in detail by one, and I will show you by referring from examples that are being considered by the IB on its own website by IB Publishing. Okay, so the first is your collection of your raw data, how your raw data should look like. So raw data include both quantitative and qualitative data, should be presented neatly in a data table. For example, there should be a proper column headings, units like voltage represented by V/unit. Now this is representing the unit and this is the symbol, so do not get confused. Similarly, current is measured in milliampere and the symbol is I. So there should be a proper column heading with units, consistent decimal places should be there, and be comprehensive. Be very comprehensive in your mentioning of your data in your table. Like for example, this table is shown an experiment to measure the current through potential difference across the resistor. Just for an simple example, and this is taken from an IB website only. So the voltage is measured, at different voltage the current is measured. So you can see delta V is nearly equals to 0 volt. It means the uncertainty in having the voltage is 0 volt. So if it is 0 volt, please mention it as it is. If it is negligible, just mention the uncertainty or the change in the voltage measurement is 0. But if it is for measuring the current, you can see there is a uncertainty of 0.3 milliampere. So you can say whatever the data we are collecting, they are measured using a certain device. So that device has a certain uncertainty, which is 0.3 milliampere. So it is already mentioned, no need to mention individually for each and every readings that you are taking, because all the readings are measured from same device, so they will have the same uncertainty. It's obvious. So mention it in the column heading itself. So this is just for your reference, how you are supposed to give your raw data in your IA. Now when you are processing your data, so repeated measurement allow for calculation of the mean value, as discussed in the exploration part. If you remember, the repetition of the trials must be taken, at least 3, as I mentioned. So you can see it is referred from again the same IB website. So here in this example, you can say calculation of the mean value with associated uncertainty, repeated measurement are used to reduce random errors. This is very important. You are repeating the same thing at the same independent variable, you are repeating the experiment and then taking the mean value, which will reduce your random errors, because you are taking the average out of your 3 trials. So the following example is taken from an experiment to measure the time it takes for a ball to roll down an inclined plane. A ball has been rolling down in an inclined plane and the time is being measured. So the distance is 1 meter. So you can say again the column heading consists of the name, that is distance, the symbol, that is as measured in meter, then the uncertainty of, like if you are using a scale, a simple scale, you can say the least count is the uncertainty plus minus of 0.01 meter, because sometimes let us say these are the 2 division and that your measurement is like this. So this is the plus minus 1, you can say the least count. Time taken, so we measure the time, the stopwatch, again whatever you are using, the plus minus of 0.01 second is the uncertainty. So you measure the 3 datas for 1 meter, you take the time taken for the ball to roll down an inclined plane, you get 6.28 seconds, 6.39, 6.31. Now the mean, this is the average time denoted by T average, again in second. Now the T average 0 plus minus of 0.06 second. This is how you have to pay attention. How will you write this thing? The uncertainty in the average value. So for that, you just see I have mentioned the calculation for you. The average is simple, the summation of all the data divided by the number of observation. So I add all the data divided by 3. So I get 6.33, which I have written in this column. Now the range, average range by 2. So that is what you are calculating the uncertainties. This is delta t. Now delta t is what? The range divided by, now range is what? Maximum value which you have get for the same trial. Like for 1 meter, what is the maximum value? 6.39. So 6.39 is the maximum time. What is the minimum time in the same trial? Is 6.28 minus 6.28 divided by 2. So you get 0.06 second, nearly rounding off. So I written this at the column heading itself. I hope it is clear how to calculate the uncertainty of the average value. Maximum minus minimum divided by 2. Maximum value from your data, minimum value from the same trial. Do not change. If it is a 2 meter, I will not take the minimum or maximum of that data. No. Of the same trial, what is the maximum minus what is the minimum divided by 2 is your uncertainty. As simple as. So where t represent the mean value and delta t represent the uncertainty. So how I will write the data? I will write like this. Either you can mention it in the decimal like in the second itself, or you can mention in the percentage also. That is also acceptable. But I generally refer the data only. If you want to write, you can write in percentage also. So 6.3, 6.33, this is 6.33 plus minus of 1%, that is 0.06 is the 1% of 6. Nearly 1%. Okay. So this is how data is being processed. This is for one calculation. Okay. Now if you look at this, how will you plot this in the graph? The error bars that I am talking about. The student calculate the square of the, now you are not plotting the graph for the distance versus time. You are plotting the graph for time squared against distance. Why this is so? That also is reasonable as per the research question. The student calculate the square of the average time. Now if you are plotting the square of the average time, so you are supposed to calculate the uncertainty of the square time. Not only, you cannot mention the uncertainty of the time only, because that we have discussed this in the topic 1 of your DP, measurement and uncertainty. Okay. So you have to take in 3 trials as shown above, also determine the uncertainty. Now how we will measure that uncertainty? Look here. So this we have got from the previous slide. Uncertainty average time as a percentage, as I mentioned in percentage, it will be the uncertainty upon the actual value. I repeat, uncertainty, that is the range that you have got, that is this, divided by the actual average value 6.33 into 100, you will get in percentage, that is 1%. Now average time squared, that is delta t square. So delta t is 6.33 square, which is 40.1 second square. The uncertainty in the time squared, if you see delta t square, so the uncertainty will be 2 times of the uncertainty in, because the power comes in the coefficient, if you remember. So it will be 1% is already, so delta t square uncertainty will be 2%. So either you can write like 40.1 second square plus minus of 2%, or you can mention what is the 2% of this. So you can say 40.1 times 0.02, so it will be nearly equal to 0.8. So this is 2% of 40.1. So you will write like this, 40.1 plus minus of 0.8 second square. Now once you get this, now you can plot this in your graph. So I have plotted at 1 meter, because the data is for 1 meter. So distance versus time square you are plotting. So distance is 1 meter, at 1 meter 40.1. So if you look at this, this is 40, this is 45. So 40.1 is nearly here only. So the circle denotes the average value, and this is the error bar. Now error bar is in the, for t square, the error bar is plus minus of 0.8. So 40.1 plus 0.8 is 40.9. So 40.9 is somewhere here only, and 40.1 minus 0.8, it will be here only. So this automatically you can use the Excel. If you want how to plot this in the Excel, please comment below. I will make a separate video in which I will explain how to enter the data in the Excel and how to plot the graph using Microsoft Excel. If you want that video, please comment in the below. I will try my level best to explain that also. So this is how the process data and the uncertainty are mentioned, and that is the part of your analysis. So if you are not mentioning uncertainty, definitely you are going to lose your marks in your Physics IE. This is the most important part of any investigation. Okay. Analysis, interpretation of the process. Now, how will you process all your data? That is I have given an example of only one data. Now you are having at least, here I have mentioned 5 data. So this is an experiment investigating the acceleration of a free fall. Okay, the free fall acceleration of a tennis ball. Okay, the student construct a graph, which I will show in the next slide, of the time squared against the drop height based on the data collection during the experiment table below. The student uses the gradient and the uncertainty to determine the acceleration of free fall with respective uncertainty. Now this is how your process data should look like. Now in this you can see it is completely correctly mentioned, all your column headings with the symbol, with the units, with the uncertainty. You can look here. It is completely mentioned. Whatever the data you are measuring, everything is mentioned. So the drop height is continuously, you can see, increasing 2, 3, 4.3, 4.8, 6.3. Now the student must give a justification of why he is choosing such heights. That is the exploration part that we have already done. Now the mean time taken to fall, that is the mean time. Again, don't say time taken to fall, because we have taken the different trials. So mention mean time. Then the uncertainty in the mean time, delta t, maximum minus minimum divided by 2, because for each drop height you might have taken more than 2 or 3 trial, 4 trial, 5 trial, depending upon your capability of collecting your data. So uncertainty in the delta t, then uncertainty in percentage, then time squared. So uncertainty in the mean time squared, delta t in percentage, in time squared in second. So this is the mean time squared, and then the uncertainty in percentage and uncertainty of mean squared in second square. So this is how your data should look like. Now it's depend, like if you don't want in percentage, you can omit that, but I have just mentioned for your reference using from, this is given in the IB site only. I have taken this example from the IB site only. This is how they expect a student to mention their process data. Look at the number of terms, decimal terms. This is how it looks like. Okay. Now using this data only, how you are going to plot the graph. Now this graph is showing how the height from which the tennis ball is dropped affect the time taken square. So on the x-axis, the mean time square, in second square it should mention the units. Label the x-axis, label the y-axis with the units and your symbol. Like here you can see displacement is height and then slash unit is meter. So you can refer, these data are plotted on the y-axis and these data mean time square is plotted on the x-axis. So accordingly, automatically your Excel will give. Now you can see there are 3 color lines: green, black and red. Now what are these? Just pay attention. Now gradient of the line. Now you see that this is the best fit. This is the line given. This is the R square, just denote how your data are relevant with your if the value of R square is near to the 1, it means your data are more clearly showing a particular trend. So you can say here H, this is the H, 3.91 t square plus 1 point. This automatically will give you the equation in your Microsoft Excel in the chart section. When you draw plot, everything I will mention. If you want, I will make a separate video on the making of your graph in the Excel. So first let us see how analysis we are supposed to do. Now 3.91, now this is the 3.91, this is the actual value of what? This is the gradient 3.91, because we know that H is equals to what? Mx plus C. Now x is what? T square, y is what? H. So you can compare this with y equals to mx plus C, which is the straight line equation, general equation for your straight line. Now comparing that, m is 3.91 I have written. Now gradient, now this again what I have done is 4.37 minus 3 point. Now 4.37 is the maximum. I am calculating the uncertainty in the gradient also using the maximum and minimum line. So this is the minimum, the red. Minimum is like the upper value of the first and the lower value of your second data. Maximum is joining the lower data of the first and maximum data of your last. So this is the minimum and maximum you are getting. So 4.37 minus 3.4 divided by 2, which gives the uncertainty in the gradient. You can calculate 0.5 or in terms of percentage as you wish. Now the y-intercept. Now if you see, the y-intercept is 1.3. So I have written 1.3. Again, uncertainty is used by minimum and maximum. Always remember the uncertainty of the equation y equals to mx plus c, like the gradient uncertainty as well as the y-intercept uncertainty will be used by the minimum and maximum line. This is the best fit. So best fit values are your average value, you can say, and for that gradient for that uncertainty you have to use minimum and maximum. So gradient ka we have already done, 4.37 minus 3.4 divided by 2, which is this, and rounding out 0.5, or you can convert it into percentage if you wish. Y-intercept, y 1.3, then maximum minus minimum, 1.49 minus 1.07 divided by 2, you will get this value. Now we know that starting with, this is the research question, it's S equals to ut plus half at square. Now we know that it is dropped from rest, so u is equals to 0, so S is equals to 1 by 2 at square, or a will be equals to 2 s upon t square. So s upon t square we have already from the graph, so 2 times of s upon t square is the gradient. Now gradient we have already know 3.91 or 3.9, directly use this. So acceleration of the free fall of the tennis ball from our data comes out to be 7.8 meter per second square. This is the final answer from the graph we are measuring, conducting all our experiment, all our data. Now uncertainty in this answer is by using the formula from the topic 1, delta A upon A is equals to delta G over G. So this is the equation. Using this equation I from this, so delta A will be delta G by G. Now delta G is what? The uncertainty in the gradient, which is what? 0.5, and gradient is what? 3.9. So 0.5 divided by 3.9 into acceleration, which we have got 7.8. So the change, or you can say the uncertainty in the calculation of your acceleration comes out to be 1 meter per second square. So your final answer in the experimentation, the acceleration of the free fall is 7.8 plus minus of 1 meter per second square. So this is how you have to make your conclusion using the uncertainties into consideration. So I hope I have explained it in more detailed and elaborative way. Even though if you have any doubt and if you want any personal guidance for your physics IA, please check the details below. You can contact me. I will be there for you. Now these are all what are the checklists you can check. The report includes sufficient relevant quantitative and qualitative data, raw data. Quantitative means you have sufficient data. Qualitative means you have take a reliable and actual, like a proper range of the data and proper trials you have taken and so on. That could support a detailed and valid conclusion. As I mentioned, you should have a proper data in order to make a conclusion. Appropriate and sufficient data processing is carried out with the accuracy required to enable a conclusion for your research question, and which fully consistent with the experimental data. It should support your experimental data. You have to make a conclusion with support of your data that you have collected and you have analyzed. The report shows evidence of full and appropriate consideration of the impact of measurement and uncertainty of the analysis. It should show the proper measurement of the uncertainty of the data that you have collected. The process data is correctly interpreted so that a complete, valid, and you should go complete analysis, complete process data analysis must be thoroughly done in order to give a detailed conclusion of the research question that you have put on. The student did make a reasonable attempt at evaluating your analysis. There should be a reasonable attempt must be given. Okay. The student has selected, recorded and processed appropriate data. appreciated the scope and limitation of the data. You should you should give a proper limitation, like if, as I stated, if you are not able to go beyond a particular range of data, you must give a justification to it. It might happen, it might differ from your topic to topic, or from your individual IA, from one IA to another IA. There is no doubt that the student has selected, recorded, processed and interpreted in a way that directly address the question. It is not like that if you are the data is something else, your research question is something else, and you are writing something else. There should be a proper alignment with your research question. As I say, the range of data must be adequate. If you are taking a simulation, the range may not be a significant issue, because in that you can there is a minimum and there is a maximum, so you can plan accordingly. So that is not an issue in case of simulation. The accuracy of the data has been represented with error bars wherever appropriate. If the error bars are significant, you have to mention it in the graph. The research question has been addressed and answered, explained and understood. So at the end, whenever your analysis comes over, the research question must have a particular, you are in a position to address, answer and explain your research question, whatever it was. So this is all about your analysis, guys. Again, if you follow all these things I have highlighted, this is directly taken from the IB guide. If you follow all this, you will be in the band of 5 to 6, and I definitely it will be 6. Okay. So thank you for with me. In the next, we will discuss about the last 2 criteria, that is also evaluation and communication. And believe me, if you have followed all these steps till now, then the evaluation and communication is very easy for you to answer. Specifically, the evaluation, communication is just a follow up of your physics IA. Okay. So thank you for being with me, and I hope you have learnt a lot about your physics IA. Continue and watch the next video to complete for your physics IA. Thank you.